All right, we got two more examples in here. So some of this is just going to be getting even more practice, getting it down to two equations, because I think that's the real big thing to come out of here is we need to be able to see how can we get this down to two equations and two variables. But this is going to show you what it looks like when there's no solutions, what it looks like when there are infinite solutions. All right, so this first one, they're just giving us that it's no solutions, but we're going to work it out and then see what it looks like so that way you know what to look for. All right, first of all, let's see what looks like it would be easy to eliminate here. I'm seeing these problems for the first time right now, so I'm looking at these thinking what looks like it would be a good idea. I noticed that we've all got coefficients of 1, right? I remember in the last video I was talking about if you see a coefficient of 1, that's a good one to go for, right? So off the bat, I'm not seeing any ones that's really sticking out as better than the others. They all seem like decent options. I am going to go with eliminating, I'll eliminate Z. Okay. If you were hoping I would pick a different one, then go ahead and try the other one. But we're going to eliminate Z. So, first of all, I'm going to do it in equations 1 and equations 3 first. All right? So if I multiply equation 1, right, if I take that and I multiply everything by 3, that's going to give me 3x plus 3y plus 3z equals 6, right? I multiplied everything in there by 3. And then I'm going to copy equation 3. I'm going to copy this. So 4x plus y minus 3z equals negative 6. All right, so look what happens. My z's are going to go away. All right, that's what we want. So I got 3x and 4x, that's 7x. 3y and y, that's 4y. 3z minus 3z is 0, exactly what we wanted to do, and 6 minus 6 is 0. Cool, so we've got one equation. All right, be aware, the fact that one of our equations equals 0, that has nothing to do with whether it has no solution, infinite solutions, or anything like that. Just the fact that this is equal to 0, that doesn't matter. What matters is if we get some contradiction later on, and you'll see what I mean when we get to that. All right, so don't worry, just because it's equal to 0, sometimes I see someone that they'll see an equal 0 and freak out and be like, oh, it's no solution. That's not true. It has absolutely nothing to do with it. It's just a coincidence that this problem happens to be the one that has an equal 0 on it. All right, so we need to do some other combination of our original equations, and we got to get rid of z. Okay, so what I'm going to do is this time I'm going to use equations 1 and I'm going to use equation 2 along with it. I'm going to do that over here. Okay? This time to eliminate z, I'm going to have to multiply equation 1 by negative 5. Right? Because look what I'm trying to do here. Right? I want this to become a negative 5z. So that way, when I combine it with the positive 5z in equation 2, it's going to be eliminated. Okay, so yes, I could have done equations 2 and 3, but look, that's a 5 and a 3. And whenever you have a coefficient of 1, that's the equation that you want to use in both of your eliminations, right? So that's why I'm using equation 1 both times. All right, and the fact that I'm multiplying it by negative 5, it's still equation 1, even if you're multiplying it all the way through by a certain number. That does not change the actual equation. Shut up. My alarm keeps going off. So let's see what we got. We'll multiply all through by negative 5. So we've got negative 5x minus 5y minus 5z equals 2. So that's going to become a negative 10. And then I'm going to copy equation 2. So we've got 5x plus 5y plus 5z equals 3. Awesome. All right, let's add them up. Those x's, look at that. So interestingly enough, when we do this, our x's are also going to cancel. So that becomes a 0. And then I get negative 5y plus 5y. That's another 0. Negative 5z plus 5z. Okay, so we actually end up with a perfect cancel on that side. Equals negative 10 plus 3. What is that? Negative 7. All right, 0 plus 0 plus 0 is 0. 0 equals negative 7. No, it does not. 0 does not equal negative 7. Negative 7 equals negative 7. Okay, so that's the thing. That's what you're looking for with no solution. So keep working through the problem as if you're trying to solve it. And if at any point you get a contradiction, now yes, it's possible that you did your algebra wrong, but Make sure you're doing good algebra, watching your steps along the way, and as long as your algebra has been accurate and you see some contradiction like that, no solution. You don't even have to keep solving it. We're not worried about this stuff over here anymore. As soon as you get that contradiction, that is going to be a no solution problem. So you can just write no solution, and that's good. That's all I need to see for those. Okay. Example 3 with infinitely many solutions. All right, let's see what this one looks like. So again, we're going to go ahead, start solving it, see what happens. Right off the bat, I noticed that my z's, those look easy to eliminate because I've got some sames, I've got some opposites. Right? I've got some opposites right there between 1 and 2, and I've got another pair of opposites right there between 2 and 3. So that's going to make for a really easy elimination step. Okay, I'm going to do that. Split those apart. Okay, so first of all, I am going to add equation 1 and equation 2 together. All right, so I got x minus y plus z equals negative 3. Whoop. And then I've got x minus y minus z equals negative 3. Let's add them up. So I got 2x minus 2y. Z's are going to cancel. Z minus z is 0. Negative 3 plus negative 3, negative 6. Again, if you have trouble adding negatives, doing stuff like that, that's what calculators are for. You can use them on the test, so use them now. Next thing we're going to do is I see another pair of opposites. Again, I eliminated z the first time, so we need to eliminate z again. So I'm going to go equation 2 with equation 3, and I'm going to once again eliminate z. And again, we can do that just by adding them together, right? This goes back to Friday. This is why you got to take notes on Friday. Because as soon as we have those opposites, all we've got to do is add our equations together, and that is going to eliminate our variable. Okay, so I've got x minus y minus z equals negative 3. And then equation 3 says 5x minus 5y plus z equals negative 15. Let's add those together. X and 5x is 6x. Negative y minus 5y is negative 6y. Negative z plus z cancels, and we've got negative 18 over here. All right, so for infinitely many solutions, let's see. Let's go ahead, start solving this, see what we can do. So I've got my two equations, right? I've got two equations, two variables. That's what we wanted. That's what we wanted. So I'm gonna underline them right there. So I'm gonna write 6x minus 6y equals negative 18, and then we've got 2x minus 2y equals negative 6. Awesome. Okay, remember what we're looking for. We're looking for opposites. So, for instance, suppose I want to eliminate x, right? It doesn't matter which one we want to eliminate. So, I'm going to want this 2 to become a negative 6. Right? Because remember, we want opposites. So think, what do I need to multiply that 2 by to get to a negative 6? Well, a negative 3, right? 2 times negative 3 is negative 6. So I'm going to take this whole equation. I'm going to multiply it by negative 3. And that's going to give us, so that top one I'm not changing, right? We want that to stay the same. So 6x minus 6y, negative 18. And then I'm going to multiply the bottom one by negative 3. Negative 6x, that's going to become a plus 6y. Negative 6 times negative 3 is 18. And if you look what happens now, 6x minus 6x is 0. Negative 6y plus 6y is 0. 18 minus 18 is 0. 0 equals 0. Okay, so again, this time we've got like the opposite case, right? We come to this some statement. It's like, wait, what is this? But it's a true statement. 0 is equal to 0. So yes, that's true. So you can just say infinite solutions. That little sideways 8 thing, if you haven't seen it, it's infinity, or you can write infinite, whatever you want. As long as I get the point that there are infinite solutions, you get the points for that question if this were a test. Okay. I know this is mathematically probably one of the trickier concepts. Maybe it makes sense. I hope it makes sense. I did my best. I know these were super long videos, but I really wanted to get through the details of the steps, especially because we are going to be seeing this for the next few days. So you will have these videos to go back and rewatch. I will also make new videos with worksheets as we come out with worksheets. All right. Please let me know what questions you have. I want to help and good luck. Have fun.